Hello. Hello, everybody. How you doing? 6:13 p.m. Central Time, July 1st, 2025. It's Tuesday night or Tuesday evening here in the USA, and I hope you are doing well. It's been a minute since I got on, but we have been remaining on live, which is good. Streaming live is a good thing, and we're not going to complain about our connection. So we're doing well, and looking at the earthquakes, there hasn't been large earthquake activity, but there has been what I would call significant earthquake activity. So going back to the start of the week, if you weren't paying attention or you weren't looking at the planet, you may not have known that multiple sixes struck across the South Atlantic, going down towards Antarctica, the South Sandwich Islands, a mid-range six. And then at the start of the week, we kicked off with this 6.1 here at the South Atlantic. That's the Mid-Atlantic Ridge, by the way. That's where that earthquake is, marked in green. Then these struck throughout the week, the other sixes, and then we go all the way across to the opposite side of the planet to the antipode, and there's our other six. Six is because one of them was downgraded, but so multiple sixes striking. Then a new swarm broke out south of Japan. There's a volcano next to here. Well, up here to the north is Sakurajima, and then there's several volcanoes out here. We may be looking at some kind of new eruptive activity getting ready to take place. A swarm of fives next to a volcano or a series of volcanoes. I don't have the name on it. What is it? Suwanizajima? I'm guessing. I'm going on memory here. Again, it's south of Japan, north of Taiwan. It's not Sakurajima. I'm pretty sure it's Suwanizajima. But you know what? Let's just go take a look together. Let's go if you don't know, you need to look it up. So here we are on Google Earth. Let's go over there to South Japan. Turn on all of our volcanic place marks. The whole volcanism program, actually. There we go. And let's zoom in. Okay. There it is. Yeah, it is. There it is. So Suwanizajima is right there. Look at the shape of the island. It's got a few other smaller islands around it. Bigger islands to the north, of course. And we'll go compare to where the earthquake is. It's kind of hard to tell, but I mean, it's right. It's so close. We'll get the coordinates on the southernmost earthquake. Or should we get one from the very center of the mix? Let's get one from the center. Of course, coordinates from the Australians, the ones you can't cut and paste easily. Okay, hold on. Let's click on another earthquake here really quick. Geophone Potsdam. Okay, that's a little better. Still have to do a little clicking around to get this. Okay, there we go. Copy and paste. Let's see if this works. Okay, it works. Yep, just south of Suwanizajima. What's this volcano called? Kusekajima. Akusekajima? Okay, anyway. Suwanizajima is the one that's always on the list. This one I don't recall ever seeing on the list. When was the last time this thing erupted here? Kusekajima is a small stratovolcano in the southern Ryukyu Islands. Most of the island is surrounded by steep cliffs, and beaches are found only on the southwest and southeast sides. The andesitic dacitic volcano consists of two older Soma volcanoes. Lava dome. Anything on the date? Nothing on the date. Let's go see when the last time this thing erupted. Wow. Okay. The Global Volcanism Program is not aware of any Holocene eruptions in the modern era of this volcano. Okay, well, all right. Well, right next to a volcano that has never erupted in the history of mankind. And that would take us back to pre-Ice Age eruptions. It's populated. And our earthquake is Earthquake Swarm. The middle of it is right south of the volcano. How deep did we go here? About 1,000 feet down for this seamount here. 800 feet to 900 feet deep there in the water. We are 11 miles off the southwest coast of this ancient volcano, and that's where the center of the little swarm is. We go a little bit north and a little bit south of there. So a little bit north would probably be like somewhere like right in here, and a little bit south would be somewhere right in here, between these two other buttes that are underwater, or volcanoes. This one is 1,200, 1,000 feet deep, and this one is 1,000 feet deep. So kind of looking at it that way, they're both about the same size. They're underwater. This one's above water. They're all the same. They're all caused by the same thing, and they're all relatively the same size. Again, just one's above water by 1,000 feet. So one, I mean, when I say all the same size, within 1,000 feet of each other. And that's something to keep an eye on, even though if Suwa-Nizijima might actually be erupting. Now, this gets into other talk, because I saw a couple videos out there, one from Stefan Burns and another one from Silky on the Pulse. And there, and as well as professionals, are all concerned about South Italy and Campi Flegrei and the potential of it erupting. And if you don't know about Campi Flegrei, let me take you over and show you it. To show you why people are concerned. Here is Italy. And a few days back, I don't have it on this feed here on Earthquake 3D. Well, hold on, let's see if it is. Nope. There was a 4.6 that struck South Italy right down here next to Campi Flegrei volcano. It's the biggest for Campi Flegrei in many years, if not the biggest in a decade or more. And this is the central portion of the caldera for it. But let me back it out and show you the greater volcano. Do you see it? So we're on the side of this, which is really a giant volcanic caldera, the supervolcano. There's other spots that have erupted next to it. And then we have the famous Vesuvius over here, over to the east, Mount Vesuvius. But Campi Flegrei is a giant ancient volcano, and you can see where it's done eruptive activity before, all the way out around the peninsula. This thing has been heaving up and down like Yellowstone does, breathing up and down, mainly up at this point, inflating. As it's been inflating, the ground's been rising. They evacuated a bunch of people. Look how many people live around here, guys. So they're evacuating a bunch of people, but it's literally Italy. Look how, I mean, evacuating people, good luck, right? A super volcano, or basically that's a giant volcanic system. Super volcano might not be the right description. Here, let's see what they have for it. A 13-kilometer wide caldera. All right. I mean, significant uplift and subsidence. Again, subsidence is just sinking. Just think of it that way. Breathing up and down. Right now, as it's surging, there's new earthquakes that are happening that are fairly significant in the 4.0 range that are causing collapses of houses and structures. Anything over 4.0, anything over 3.0 can cause significant damage in Italy due to the structures, many of which are, let's see if we can get a street level on this, stone stack cinder block or similar. And look, I mean, okay, I mean, okay, so that's where we are in Italy at the volcano that professionals are worried is going to erupt at some point soon, but no time frame is being put on it. So whenever there's anything seismically happening at the location, everybody's alarm bells are going off, except for mine. Why am I like seriously now, guys? Why am I the only person that's like, it's good? I just don't know. Something about this to me says that it's just breathing. It got directed a seismic wave. Let me show you other examples of other larger volcanoes up to the north. This is Italy now. So this, see, Colli Albani? Albani? Okay, it's a stratovolcano in its own right, but around it are these. And that's not from just natural. Look at it this way. There it is. The whole thing is a giant ancient caldera. You see it now? This is the center of it where they have it marked, but really you need to pay attention to the whole thing all the way around it. Then, oh, somebody's really rolling out there. We have another one up here, the Sabatini complex. And another one, Volsini. See how big these are? In comparison to Campi Flegrei, I would say this greater crater caldera is about the size of the other calderas up north, but Campi Flegrei next to it is more like one of the smaller ones. So is it going to erupt? I'm saying no. I don't think so. What I noticed happening was something down here. This thing, see this? Looks kind of square-like, but turned sideways. Out here, back behind it, is the plate boundary that goes up to the north on the east side of Italy and goes all the way up this way. It comes back down and meets up here at the Ionian Range. Well, at the Ionian Sea, we used to have a fair amount of activity that would let us know something was coming into Italy. And instead, right about here, we've been seeing a lack of large earthquakes or significant earthquake activity. And instead, it's been striking back in here. This is the Aegean Sea at Greece and Turkey. And same time that all started happening, where the earthquakes somewhat puttered out here and instead started striking here, Santorini, right down here, started to inflate. Cracks in the ground, evacuation orders issued for people around the volcano here in Greece. Talk from professionals, they couldn't figure out whether it was Colombo, the ancient volcano that's down here under sea, or Santorini itself. Then the wave, the seismic wave, started going around the outside edge of Europe up this way, up through Romania and Poland, and out to the North Pole. Italy being left out of the mix for the most part. Look at the earthquakes over the past several days. A stepping stone path of the mid-range 4 level, all the same sized earthquakes, 4.6, 4.7, 4.6, 4.7, 4.0, 4.0, 4.0, 4.0, 4.0. So it's 4s and 4.7s going all the way. Think of this like a wave in the ocean, where the peak is 4.7 and the low point is 4.0. A wave going across all the way over to Europe, and it's getting right to here. And in the past, we would normally see the seismic wave go down and around and up into Italy, following the plate boundaries. So maybe I should open up a USGS reported earthquake at this point, just so we can see the plate boundary. Here are the plate boundary complexes, and here we are in Europe. So it's like a letter J shape. In the past, wave comes over, goes to here. We get an outbreak here, letting us know something's coming in. Then goes up in Italy, dead ends into Turin and Milan. Get outbreak up in Turin, Milan. Get outbreak across the plate boundary in Italy. Then the rest of the energy would go around the outside edge of Europe. This is in the past. Would go around the outside edge of Europe and go up this way. Well, something happened down here, south of Italy, west of Greece, in the boot tip of Italy. An earthquake struck down there, a series of earthquakes struck right here at the boot tip of Italy. Somewhat rare. And when I went to go look at it, I went and looked live with my viewers, and I found something there that was significant, but would push the realm of believability as to what it is. See, I turned it on its side here, but there we go. So proportionally spaced out and at the same elevation all the way around. But look at the size of this. Is South Italy now. So whatever this would be, possibly ancient. Well, we know it's ancient, but is it possibly made by someone? We don't know. There's no way I'll ever be able to prove that. But when a series of earthquakes started to strike Italy down here, that's what led my eye to this. Then an outbreak started where this thing points right up here. And ever since then, we've been getting a reflection of the wave that comes in and goes back and comes in and goes back to the Aegean Sea, and then around the outside edge of Europe this way, out towards our letter X, X's. And we're seeing activity from Iceland to the North Pole. Meanwhile, where are the earthquakes at the Azores? Where are the earthquakes across the North Mid-Atlantic Ridge? You guys remember how many happened last year? Sixes and upper sixes. Large earthquakes were happening up there. Then Iceland erupted. And then this happened in Europe. The waves started getting directed around the outside edge, and that's where we are today. So is Camp Flegrei going to erupt? I think no, personally. Just if you, again, I'm not trying to conflict with professionals and all the video makers and everybody's concerned. I understand. It's better to be prepared. Don't be scared to have all the information. You need to consider all possibilities. So Stefan and Soki and all the professionals, they're all good with me when they're worried about this because of the amount it's heaving upwards. It's inflating. Now, what I think is inflating it is the seismic wave coming in, going through this thing. It's directing it up to their magma chamber, basically, and it's reflecting back. It's going back through it, back over to here, and the wave is bouncing around in there before it goes around Europe. Sooner or later, we'll break with a new earthquake in between Camp Flegrei and the Ionian Sea, and that would hopefully redirect us back the way it always was, which is going up the plate boundary into Europe. That's not good for the people in Italy, though. They'd probably rather see it happen like this, which is, seismically speaking, not good for the people in Italy. I mean, that you'd want the wave to reflect out of Italy and go around Italy altogether and skip Italy and no more earthquakes in Italy on the plate boundary. Now, if that happened, I think the whole world was falling apart. Now, deep earthquakes are carrying on our letter Ds. If you're new here and you don't know, the letter D stands for deep earthquakes, so it's a spot where we watch for new deep earthquakes to take place. And you can identify their deep earthquakes by how they're raised off the planet. So you see, our letter D here has a set of deep earthquakes right in the middle of the letter D. The rest are up towards the surface, hugging the Earth. So these are down below, and we have another set on our letter D there. And up here to the north, up at Japan, just north of our letter D, another deep earthquake there. So these are forecast area points where we expect new deep earthquakes to take place. We go all the way over to the Mideast. We have one more final letter D, and right on it, or right next to it at the tip of the arrow, a deep 4.7 raised, somewhat higher than the rest. Again, deep, 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 all the way around. Now, other side of the planet, our other letter D, right in the middle of it, new deep earthquake there. And it looks like a pincushion going from central Chile all the way past Fiji and Tonga, through the south tip of Indonesia, up through Japan, and over to Afghanistan. And if we really go this far, we go from Afghanistan to Chile, it's half the planet. They're antipodes of each other, basically. So deep earthquakes are occurring in a large, broad area in a short period of time. In the past, when we get a series of deep earthquakes, several of them that happen across from half the planet, it means something's going on down below the plates. And that's what these deep earthquakes are signifying, that something's happening down there, causing the deep earthquakes. So what's causing the deep earthquakes? Well, some kind of very low frequency of some kind, a seismic wave, as we call it, but it's coming up from deep down below. Don't know if it's coming from the core or just outside the core. But it's vibrating up an electric current that's coming up to the bottom of the plates and hitting, and where we get the hit points, that's where the wave comes up, and then it comes up and spreads out. I'm just explaining this for new people in case you're new. So when I see a whole bunch of new deep earthquakes happening in 48 hours, this is 36 hours, here's 48. We can even add one more deep earthquake where we don't have a letter D, and that's down here next to a volcano at Nicaragua? What volcano is there? Hold on. Hold. Pulling a Braveheart on you here. Hold. Baru. Oh, Turrialba. Turrialba volcano, right next to Turrialba. All right, well, Look, deep earthquake next to a volcano means something's going on down next to the magma chamber, and we'll have to watch it. Turi Alba. At this point, I probably should check the Volcanic Ash Advisory Center. For crying out loud, let's go look it up. Let's see. VAAC, Volcano Discovery. There we go. Let's see who's on the list for today. Reung over in Indonesia. That's 13,000 foot high, flight level 130. Ibu, okay. Yeah, Kirishima. Kirishima volcano is erupting. Hold on. That's right next. That's the volcano in South Japan. I guess I should have checked this first. Look, Suwanee-Zajima exploded. Hold on, how big? Exploded. Not identifiable from satellite. Flight level 180. Maybe it's cloudy that. Semeru in Indonesia again. Fuego in Guatemala. Dukono. These are somewhat regular eruptors. I would say Raung is the one that we don't normally see on the list very often. Suwanee-Zajima. Okay, don't need to say that again, but this one here too, Kirishima, is not normally on the list, at least in the past 15 years that I looked at it. Semeru, Reventador, Ibu, Kirishima again. Semeru, Reventador, Dukono. It's like a repeat. The repeat offenders over and over again. Luitolo in Indonesia. That's low-level eruption, 080. Okay, I'm not. Oh, Popocatépetl in Mexico is back on the list. Chevauche up in Russia is there on the list. Northwest Pacific. And that gets us, we're getting back several days. I just have to look at, I haven't looked at this in several weeks, actually. I haven't looked at this, but there we go. So that being said, let's turn that off and just go quickly run down the quakes one more time with the new information that we have, which is, well, looks like we might be having an eruption at Suwanee-Zajima and Kirishima over here. Here's Suwanee-Zajima and Akuse-Kajima. Kirishima is, there we go, right here. So I'm just going to say it, we're one step away from an ancient volcano erupting. Down to the south, we have several erupting in Indonesia where these letter V's are. That's where Ibu is. That's where Dukono is. I am not familiar with Raung volcano, where it is. Raung volcano, Indonesia. Where is it? Okay, it's down in Java. Here's Mount Raung. Here's Java. Here's Sumatra. We'll back it out further. There's Australia for reference. But on the east side of Java, that's where this volcano is, right next to where the earthquake is. Okay, all right. It's important to note where the volcanoes are, and you will start to see that there's a correlation between the seismic and the volcanoes for sure. Anything else worth mentioning before getting into the United States? Well, let's talk about Hawaii. So, big lava fountains keep happening at the crater for Kilauea. Seismic is, well, as you would expect, around the whole island as this thing keeps venting out more and more lava. But man, it's venting. It's not just effusive flow. It's straight up shooting out huge fountains of lava, 1,000 feet high. Really cool looking. Go over and check Doing Hawaii. That's a live stream on YouTube. I recommend them highly. And yeah, just incredible stuff. Oh, and 2 pineapples as well. 2 pineapples and Doing Hawaii. 2 different channels. Awesome in Hawaii covering the volcanoes. Now, 1.9 up at Mauna Kea. That's where the observatories are. They don't normally expect any kind of eruptive activity at Mauna Kea. So I don't think this is related to eruption. I think it's related to a seismic increase that's getting ready to take place. We might be talking about a new 4 or a new upper 4, maybe even a low 5. Somewhat rare for Hawaii. Only happens a few times a year. But I would watch out for it. Look, I mean, when you start seeing seismic at the other volcanoes and they're not going to erupt, that means something's going on down below that's causing activity at the ancient magma chambers. And if you go up here and look off the northwest coast of Hawaii, you're going to find another ancient volcanic field. What's the name of the place? Oh boy, Laihi. I guys, I'm rusty. Look, I used to have all this memorized. Can you believe it? I used to have all this freaking information memorized. What? I don't know. Let's go see. Northwest Hawaii. It's an ancient volcanic field right here. There's Hualalai, Kohala. What did I say? Laihi? Where did that come from? That's not even a name. There's Hualalai. There's Kohala. I don't know. It sounds good, though, doesn't it? Laihi? It should be. Go ahead and call it the Laihi volcanic field out here off the coast. Name it after the Dutch Laihi field. Okay. So you can clearly see out here off the coast, we've got craters. They're not very well imaged. This is undersea, bathymetric undersea imagery from sonar, basically. But on land, there's two sets. One right here just keeps going, and you'll see some of them are more pronounced. But they're ancient. And they go down to the sea. They just keep going. Of course, they're weathered over by the ocean. But there's another chain of them down to the south at Hualalai that's much younger. But it's doing the same thing. And they go down towards the ocean. You see how many there are, spatter cones and little outbreak points. Now that's probably tied to the greater Mauna Loa complex. These smaller, but still very impressive large volcanoes. But they might have their own magma chambers. I don't know. The point is that whenever we see earthquakes going on at Mauna Kea, up here at Kohala, down here at Hualalai, and if you go down to the active volcanoes, the one that's putting off 1,000-foot regular flow in the inside of the crater there, and then you got to remember Mauna Loa erupted this past year first time since 1980 or something. Was it 81, 84? The early to mid 80s was the last time it erupted, and then it erupted last year. Mauna Loa did. So it means seismic is going up and trying to find a way out. That hence the waves seeking out these ancient volcanic complexes before breaking somewhere across the island much bigger. So I think of it like this. There's a wave trapped in here, bouncing around. And it's going to keep bouncing around until it breaks. And the more energy that keeps getting pumped into it, where's the energy coming from? We have to trace the Hawaiian island chain back to here and then hard north. Right. Hold on. I hear sirens. Hold on. Anytime I hear sirens in the summer, I think fire or something. You know, like when you live around a wooded area, you hear sirens. You're like, oh god, you hear fire sirens. Okay. People are partying. You know, that's how it goes. So in the United States now, in Hawaii, so we look for up to 4.9 or low 5 in the next few days. I would think in the next several days that would happen. I'll also watch the lava flows inside the crater. It's just awesome looking. It's the coolest looking thing ever. It's not dangerous. This is the kind of lava flow you want to see if a volcano is going to erupt, where it just keeps filling in a giant caldera with layer upon layer. But you have to remember that the the entire crater complex for Kilauea sank and went away. So it needs to refill. All this sank. This wasn't like this before. You see all these cracks here? A few years ago, this whole thing drained out and then it collapsed. And all the lava that was in here came out off to the side out over here and flowed out over here. It was huge. It was huge lava flows happened when that happened. So in this case, this thing is refilling with layer upon layer of new igneous rock or lava that comes out at the top and then hardens. So incredible looking, cool to watch. Keep an eye on it. Seismic, I think we're going up to 5. Let's look at the United States now. Going across the U.S., let's just quickly take a glance, turn off the numbers. And there we go. So hopefully you guys can see all this, and hopefully you can hear me. But looking at the earthquakes over the last 48 hours, this is just 2 days, but let's look at the whole week. So the whole week really, really shows it, especially up to the northwest. Do you see our line of earthquakes? We're looking at everything 0.0 and greater from the USGS, just so you know. But I turned off the numbers just so you can see the actual pattern of the earthquakes. So do you see how the earthquakes make this arrow-like shape here? Going across Idaho and Montana down to Yellowstone, and then going back across Idaho this way over towards Oregon and Washington? It makes like an arrow shape, doesn't it? Now, a long time ago, I noticed, this is 14 years ago now, 15 years ago, I noticed that this was happening. The arrows weren't on the map at this point. I just noticed the earthquakes were going this way, and that they all pointed in a general direction. Same with down here, that if you follow the earthquakes out of California, you see they make a pattern, a path across South Nevada, and they pool up here like another large arrow going across Utah. And this was 14 years ago that I noticed that was going on. And then I noticed that earthquakes were going down through South Colorado, making a bend through Texas, and going up this way till we got to the center of the plate. And in here, all of these oil pumping operations were getting hit across Texas, Kansas, and Oklahoma, and southern Colorado. Every single earthquake here across Kansas, Oklahoma, Texas, and Colorado, every single quake is next to either an old drill point or a current one for oil or gas, or both. Not just wastewater disposal, oil wells, old capped off oil fields in Kansas from the 1950s, getting hit as this seismic wave is trying to make its way across the plate. And it follows this, which I show all the time, but I will show it one more time right now, the edge of the North American craton. And the seismic wave is just trying to find a path of least resistance to out across the plate, going from one side of the plate to the other. It's coming from the Pacific. The seismic wave is. Now, the plate is moving in the opposite direction. You got to remember, this is happening down inside the plate. Up at the surface, the plate's moving like a log rolling over in a river, staying in place somewhat, but still rolling over. While the earthquakes are going one way, the plate's going the other. Like your cell phone vibrating across the table. The vibration's going one way, but your cell phone's going the other. Okay, so the earthquakes are following the edge of the craton, which just proves that there's a wave that's following the edge of the craton. And it's just dropping off the quakes along the way, and the wave is pointing in a direction that it's going. Once we get out of the Midwest, Colorado, Kansas, Oklahoma, Texas, now we could spend the next hour looking up all of these earthquakes in Texas and Oklahoma and Kansas. I can do that to prove to you, if you're a new viewer, if you need to see that there's oil and gas pumping operations at every single spot. But I mean, I'll just grab a few random ones of the biggest out of the bunches that are there, and we'll just look them up. And if you are curious, you will definitely go grab the coordinates on the 0s, 1s, and 2s and put them in to go look them up to verify that they're directly next to oil wells and gas wells, not just wastewater disposal. But zooming in, there's a giant solar farm right here. Your eye would be drawn to this giant power generation station producing VLF, electrical VLF. But right next to it, you might also catch the gas pumping station there and all of the frack wells and oil and gas wells that are placed out. Now, this is Texas. Everybody knows. We're all familiar with Texas. Nobody's going off, but when you start to see the number, first of all, back it out. See all these squares on the ground? Every single square is a drill point. When I say square, I mean all these little dots that are on the ground. Every one of these is an oil or gas drill point. All right, so just so you're aware of how much is going on there. We're right on the edge of a very large oil and gas pumping operation, coming right out to the solar farm that's producing electricity that's very low frequency in nature, 60 hertz, something like that, coming out of there and going out in transmission lines above the ground. So you got two things going on. You got large drill points, many of them with metal casements that go down a kilometer into the ground or more, 1,000 feet or more into the ground, and at an angle. Think of these like large strings in the ground to pluck. And right next to it, we have above the surface a very low frequency being generated. Then to top it all off, inside of the plate, inside of the edge of the craton, we've got a very low frequency passing through from Mother Nature that's generated on the other side of the planet down below, and it's trying to find a way out. It's trying to find a way out and around. As the wave goes through these areas, the volcanoes, the drill points, they vibrate in a way. And we get earthquakes along the way that break as the wave gets caught in an area. So we have a 3.2 at a drill point there, and all these zeros, ones, twos, and so forth all around it, or all at other drill points. Obviously, you can see how many there are in Texas. And that's just the first spot that I looked up. If you go here into the middle of this cluster here, this gets into Midland, Texas. Very famous location, Garden City, just north of Midland, or I'm sorry, just east of Midland. And if you're not familiar with Midland, that's where the Bush family is from. And we're going to go put the coordinates in and show you what's all around the area. It's just like the spot I just showed you. Again, I mean, first of all these little white squares on the ground are different drill points. Here's the earthquake epicenter, and right next to it, a few dozen feet away, right, one city block, we've got our oil and gas wells here. This is, I think, wastewater disposal going on. No, we got oil going on at these. Oil and gas. Large operation. Look at it. So drill points there in the middle of that whole cluster. And if you go up into Oklahoma, it is the same thing. Okay, so the only one that people would have a hard time looking up would be these earthquakes in Kansas. You got to know where to look this up. And Kansas has a state website where you can pull the old well information. And I guess I should just do that now at Woodston, Kansas here. Let's see. Kansas oil well gas map. See if it brings it up. Oh yeah, okay, good. Top search. Here's our interactive map. And we want to go up into central western Kansas. Let's put the coordinates in for the earthquake for the 3.4 up there, because it's a significant sized earthquake. I mean, again, it's not like Kansas gets hit all the time. Only when there's a wave equal to 3 point something going across the plate do you even get this kind of activity. What do we got going on here? Cattle? Okay, cattle. Again, like I said, it's an old oil pumping operation. So, oh, look at that. Oil and gas well. Wow, we've got one marked and still on the surface. Right there next to it. I bet there's more. Where there's one, there's more. I have the nearest mark from a oil pumping operation and frac well operation there. We should probably mark this at this point. What date was the earthquake on? Okay, that's the Texas quake. It's Hawaii. Hold on. I thought I clicked on that earthquake. Hold on. Let's get it again. There we go. Woodston, Kansas. It was on June 25th. So really at the start of the week. It was, 6 days ago almost now. So copy and paste that. I need to mark this for future reference since it's such a significant size quake. Bear with me as I do this live. 3.4 June, was it 25th? Or is it the 26th? Hold on. Damn it. Okay, I got it right. Okie dokie. So we're on the edge of a large oil and gas pumping operation. We're a matter of a mile away for this one. Again, 2 county farm blocks, if you want to think of it like that. There's probably more in here. Oh, look, a large microwave tower. Oh, nothing go wrong there. Earthquake next to the microwave tower. I'm willing to bet there's an old drill point here that the 1950s oil field is also from here. It's got to be. It would be marked, and I'm going to bet this is like leftover remnants from it or something. All right. I start to daydream. Let's go and carry on over to the east. So while we get 3s going down through Texas and over to Kansas, we got a 3 down in southern Missouri. This fulfills my forecast for Missouri, by the way, which I issued a warning last week. Very rare for me to do. I only have to do this a few times a year when it comes to warning Missouri. I think so far, knock on wood, we got lucky. We came in about a half magnitude under. And the location, though, wait till you see this spot. Hold on, let's just make sure what the USGS says about this. A 10-kilometer depth. Now, one more time, look at the screen. Whoops, not there. Here. Edge of the Craton up into Missouri. But the better way to see it is this way on Google Earth without all my gobbledygook on here, by the way. Let's turn off all my place marks. And then you'll hopefully be able to see it. It's an N-shaped bend that goes down to a U-shaped bend down through the south, down through Alabama and Mississippi. But it goes into an N-shaped bend up here through Missouri and South Illinois. And then it goes to the west, the edge of the Craton, down through Texas, through Dallas, Fort Worth. This is Dallas and Fort Worth, right through the middle of Dallas, Fort Worth. And then the edge of the Craton makes a bend this way. It looks like a river, but really this is a bulge, 1,000-foot high, all the way across it. This is the bulging edge of the Craton that goes up, around, back down, and then it's obvious up the East Coast. So the wave is going down through Texas, going up through Oklahoma, going over to the New Madrid, and now it's going around and up the East Coast, dropping off earthquakes all the way along the way, equidistantly spaced no less, going across New England, up into Maine, right to the Canada border. Now these are all small earthquakes. It's 3s, 2s, 1s across the plate as the wave is spreading out across the plate. But that's not really that much loss of energy across at that big of a distance. So, whoops. Man, I keep clicking the wrong button. There we go. So up the East Coast, it's a perfect match. This is the last 6 days of 0.0 and greater earthquakes. What does this prove? It proves that there's some kind of wave going around the edge of the plate, and it's seeking out a path of least resistance, going around the edge of the Craton. And it's dropping off the same-sized earthquakes all the way across the plate, and it's only losing a magnitude of energy across each region as it goes from region to region. And sometimes it doesn't lose much energy at all, and we can see relatively the same-sized earthquakes, 3s for instance, go all the way across the plate, or 4s all the way across the plate. The biggest I've ever seen was 6s that went across the plate, 5.9s. And it started with a 6 up in the northwest, and 2 weeks later, or less than 2 weeks, a 5.9 struck in southern Colorado, and then 12 hours after that, a 5.9 struck in Virginia. This was in 2011. So first a 5.9 in southern Colorado, then a 5.9 in Virginia. They were 12 hours apart. What do they have in common? This. Colorado, southern Colorado, right in the middle of Colorado's border with New Mexico. That's where the 5.9 struck. And over on the East Coast in Virginia. So a wave equal to 6.0 flowed across the edge of the Craton in 2011, and it dropped off 6s all the way along the way. Eventually, we got an outbreak of 4s and 5s that follow the arrows out to the Azores this way. That was in 2011. Now it's 0s, 1s, 2s, and 3s right now. So we're half of where we were in 2011 right now. Now the locations are all spot on. Let's go back to Missouri now and search one more time. And where are we coming in? This is an interesting location, guys. Let me tell you a little bit about it. I'm from Missouri, in case you don't know. But look what's on both sides of the river. High voltage power lines, right? Now, you can follow those high voltage power lines. They'll go back. Missouri's got a spider web of them that goes back to our nuclear power, and we also have coal fire and gas fire power plants that power that. So this isn't coming from a power plant nearby as far as I know. However, we zoom in, you got houses. You zoom out, you got power lines. You zoom out further, and we've got the edge of something that I don't know if I should talk about at this point, but I'll just make you aware of it so that you know what to look for in the future when I do bring it up. This is the United States, and this is the earthquake we were just looking at right there, just as a point of reference. Now, I'm going to blank that out so you can see this perfectly. Remember, the earthquake is right down in here, but we need to turn the Earth. Okay. This is Florida here on the left side now. But our earthquake was right down here. And the reason I turned the Earth is to show you this in the center of the plate. This five-sided thing here that's in the shape. Now, in St. Louis, there's another one. And it's ancient. It goes back 400 years or more. And now it's being made into, it's here on the north side of St. Louis. It's still in the streets. The streets still show the shape of it, but it's on old maps as well. An old bastion fort, the same size now, or the same shape, the five-sided pentagonal star-like shape or arrow-like shape. But this building in the middle, that right here, is a housing project from the government. But this is the new geospatial agency for the U.S. government for all the mapping to be done in the world, mapping of the topography. And this is the old bastion fort from the French, and it's still in the shape of the streets there. And that's on the backside of this giant 300-mile long one here. And the military base in the middle and in the tip. In the cities on all five sides. This is five-sided pentagonal. Now, why does this matter? This matters because of the earthquake. The earthquake happening on the side of it. And it's significant. It's a near 3. It's the first 3 in Missouri in many months. Why does it matter if we have an earthquake on the side of a five-sided pentagonal star fort shape? And that it's 300 miles long? Well, let's go and look at one other thing. Let's look at the earthquakes on the South Pole, which we don't get a feed on. We don't actually get a view of the earthquakes at Antarctica, but we get everything around Antarctica. So when you look at Antarctica, you've never been shown this by anyone, I guarantee it, unless you are a viewer of mine. You'll see earthquakes on the left side of Antarctica, the way we're looking at it here, and on the right side of Antarctica. But what I want you to do is to look at the outside edge of the plate boundary that makes up Antarctica itself. So we have 1, 2, 3, 4, 5. And this is my copy of Earthquake 3D, but let's go over to Google and look at what they have for Antarctica here and look at it the same way. I'll be darned. It's showing the same thing, which is the outside edge of Antarctica is the same five-sided pentagonal star fort, bastion fort shape, but it's not 300 miles long. If you go down here and go to the middle of the plate boundary, you'll find that right here along the plate boundary, they took some ships out here to get high-resolution imagery of this volcano out in the middle of nowhere. And that volcano is right there on the very middle back side of this five-sided star fort shape. And if you go from that volcano right through the middle of Antarctica, out to the very tip of it out here, look where you go through. The South Pole. This is the exact South Pole here on Google, which they don't show you a very good shot of. You can zoom in and click on the pictures. Anyway, so if you measure from the plate boundary, where they took all this time to come out here and scan the heck out of this freaking volcano it doesn't even have a name on it. But I'll do it for you because this is going to blow your mind. Get ready. So we go through the South Pole. And by the way, Google is adjusting for the curvature of the Earth. So you can't say that this is like, a linear measurement that's gone wrong or something. We go right through the middle of the South Pole and we come out to the tip. Whoops, the curvature of the Earth kind of messes with this. See how it bends it over the South Pole, even though I just drew it over the South Pole? Anyway, we go out to the tip of here and we go down to the plate boundary at the furthest point right here or here. There we go. The furthest point at the break of the tip, and look at what our mileage is. 6,660 miles. Now, what's our elevation? We're at this point, we are negative 12,000 feet, but it goes deeper. We go down to the bottom of the ridge. 13, 13.5, 13.6, 13.6, 13.7. Trying to find the, let's zoom in some more. There we go. 13,760. Look at our mileage now. At the deepest part of the trench. So the top is 6,660 miles, and then it's a 6-mile long descent down to the bottom. And the actual measurement from the backside, and I'm not fudging this at all. Look, it's 6,666 miles from that volcano at the backside all the way out to the tip. And I could not believe it when I measured this. I was like, oh, uh-oh, uh-oh. I'm not into that numerology thing or anything. I'm not superstitious or anything. But you start finding crap like this, dude, it's going to make it'll grow hair on your chest when you start seeing it in your own backyard and you've got a 5-sided pentagonal star fort shape. Now, guess what's on the left side of here? I already showed you St. Louis, and I already told you about the military bases in the middle. Guess what's over here on the left side? Let me turn on my borders and labels and show you. Right here is a quaint little town called New Madrid, Missouri. Okay. Now, as if that wasn't enough, next to New Madrid is this small one. A small one, 6 miles by 9 miles. Small one, but there's something in the tip of it. Or at least there was the last time we went and looked. Let's see. Is it still there? Yeah. Somebody knew we were looking. By the way, when I showed this first, and this is not from farming, guys. This rises, let's see, 150 feet. This whole thing is 150 feet high. It's 6 miles by 9 miles. And it used to overlook, like a bastion fort would, over the river, the Mississippi River. But somebody a long time ago built this. And I dare say the French and the Spanish didn't have earth-moving equipment to build 150-foot high, 6 mile by 9 mile long star forts. But nonetheless, this is next to the town of New Madrid, and this is a microcosm, a small version, of the big one. And the big one points to something. The big one here in the United States, if you go right through the tip of it, it points out in a direction. Well, here, let me show you. It points to the West Coast, doesn't it? Again, I'm trying to get through the center there. Pretty good. You see it's going pretty good right through the center there, right through Muskogee. And where does it take us? It takes us down to Baja, California. But there's something here. The famous, and I didn't know about this until we did this measurement, came in, and this is the famous underwater weird measurement location where they tried to say it was from submarines that were in the way, or there was all kinds of excuses made that they said that this was not really there, that it was just a bathymetric image artifact. But it turns out these are actual mounds and depressions. And this is, depth is 5,000, it's a mile deep. That's 5,000 feet under sea coming out of the plate right there. And this thing points right to it. We got the biggest earthquake in U.S. history on the left side. We got the biggest mounds in U.S. on the back right side. In the middle, you got the military base. And deliberately flooding it at Branson. And out at the tip, you got old Fort Gibson. Somebody might know, It's starting to look like somebody knows. People, 133rd degree. I'm a 234th degree Order of Dutch Fellows. I had to start my own society because they kicked me out of all the others if I would have tried to join. They won't let me in. I never asked, but I don't want to, Figure everybody would have to ask to join mine, you know? Start finding weird stuff when you're sailing out here alone in the Flying Dutchman ghost ship, forever doomed to sail the high seas of the internet. Glowing green from radiation, taking Fukushima readings after everybody else cowered it out. You know what? You know I'm an idiot because in 2011, I bought Geiger counters when no one else could even get them, right when Fukushima happened. And when they shut off the EPA radiation monitoring stations on the West Coast when Fukushima happened, in case you didn't know, poof, off they go. Obama's president. Fukushima's blown sky high. Obama gets up. No radiation is going to be reaching the shores of the United States. And we're all like, yeah, right. Let's check the EPA site. And then, all of them off. And everybody's like, what's the radiation? What does anybody know what radiation levels are? Anybody got a Geiger counter? And they're all sold out. Luckily, I got my hands on a couple. And I decided to drive across the country taking radiation readings to find out, is there radiation reaching the United States? Guess who else did it? No one. Out of 350 million Americans, no one got in their car and drove across the country taking readings. Few people did readings in their own town, and that was it. Maybe if they got lucky, they put it on YouTube. But that was it. Nobody did any readings. No professionals did anything. The government didn't dispatch anyone. No media did it. I did it. And I did it live. I documented it all the way across the country as I drove with my wife across the country taking radiation readings. Got all the way to the West Coast. It was just a few weeks after Fukushima blew. Supposedly was putting off just huge amounts of radioactive material up into the sky. I decided to go out to the semi-rainforest of the Pacific Northwest, out on the coast of the Olympic Peninsula coast, at a town called Forks, Washington. Just by chance, ended up in a vampire town. Didn't know that it was the place where they filmed Twilight, the series. But anyway, ended up in this vampire town filled with goth people. And I decided to take the radiation readings out on the beach of La Push, Washington, in the rain. That's how you know I'm stupid. Because what if there was hot particles in the rain and I'm sitting there getting rained on? But you know why I did it? I did it because nobody else would do it. And because I wanted to know, is there radiation in the water coming down? Is there heavy particles? Are we getting anything? Guess what the results were? Well, turns out Fukushima was somewhat of a scam. And Obama was right, but not because of reasons that I can't tell you. And to top it all off, you might catch an episode of me on the nightly news on NBC Nightly News, being interviewed by NBC as asking me below the St. Louis Arch, no less. They met me below the St. Louis Arch, asking me about my radiation readings and why I was doing them. And I said something like this. Well, this is me back in 2011. Young man, still confident in myself. Well, trust but verify. The government gets things wrong all the time. This was before I was totally awake. I thought I was awake. I thought I knew a lot. This is before I knew anything about the secret societies and everything else like that. I had no idea who was interviewing me or what was going on. I thought they were actually interested in radiation. Turns out they were more interested in me. All right, so why am I telling you the story? I'm the glowing Flying Dutchman, glowing off on the horizon, untouchable by the rest of the internet, as I am also a pariah and to be avoided as a sign of hitting rocky shores. So if you try to chase me, you're going to hit rocky shores because I'm a ghost ship off on the horizon, dude. Fukushima, you remember? Heartbrings, Radiation, radar pulses, that kind of stuff. Got me banned off the internet. Now I do earthquakes. I'm a nice guy. I'm Mr. Earthquake. That's all I am. Don't ever ask for anything more. All right. You guys, good morning, good afternoon, good night, good evening. Hope you enjoyed this update. This is not a forecast. This is just your update.